The focus of our lesson for today is the most essential learning competency. That is for you, dear learners, to perform the fundamental operations on integers. As for the reference, we will be using the Compendium of Notes in Mathematics 7 by the Schools Division of Tarlac Province. Let us begin by defining what integers are. Do you have any idea what integers are? Now that we have defined what integers are, let us try to solve problems involving the fundamental operations. I want you to observe the examples and see or formulate the rules that we can follow in adding integers. For the first example, we have positive 27 plus positive 12. And for the solution, we are adding the absolute value of 27 and the absolute value of 12. As we add that, the result is the absolute value of 39. And we know based on our previous lesson that the absolute value of 39 is positive 39. For the next example, we are adding two negative integers. Negative 20 plus negative 15. For the solution, we are adding the absolute value or the negative, and then we have annexed the negative sign and then added the absolute value of our addends, 20 and 15. When we add that, we will come up with 35, but we still have the negative sign outside our parentheses. And using our rules in absolute value, since the negative sign is outside our bars, so the answer is negative 35. With that, what did you observe when we are adding integers with the same signs? For example, A, they are both positive. For letter B, they are both negative. Okay, so if the integers have the same sign, just add the positive equivalents of the integers and attach the common sign to the result. That is our rule when adding integers with the same sign. To summarize, when we are adding a positive plus a positive integer, the sum or the sign of the sum is positive. Likewise, if we are adding a negative number to a negative number, the sum is negative. We just have to add our addends and annex the negative sign. Remember that for adding integers. Let's continue with these examples. This time we are going to add integers with the same or with different signs. We are adding 38 or positive 38 and negative 20. Let's look at the solution. So it says there, get the difference between 38 and 20. The result is 18. And since 38 is greater than 20, the sign of the sum is positive. Hence, 38 plus negative 20 is equal to 18. Given that example, can you give a rule that we can follow in adding integers with different signs? What operation are we applying? That's right. If the integers have different signs, get the difference, or we subtract the numbers, and then attach the sign of the larger number to the result. In short, when we are adding a positive and a negative number, we have to subtract their positive equivalents and then get the sign of the larger number. So that applies if we are adding negative and a positive integer. Here is another example when we are adding a negative and a positive integer. So for the solution, since they have different signs, 42 and 16 will be subtracted and their difference is 26. And since 42 is larger and its sign is negative, so the sum is negative 26. Let us continue with the rule in subtracting integers. In subtracting integers, we follow this rule. Add the negative of the subtrahend to the minuend. For example, 10 minus 6 is equal to 10 plus negative 6. What did you observe? We have changed our operation into addition and then change our subtrahend with its opposite. Since in our original problem we have positive 6, it will be changed into negative 6. That's why we can rewrite 10 minus 6 as 10 plus negative 6. And we can apply our rule a while ago in adding integers with different signs. And when we add those two, we will just subtract 10 and 6. So 10 minus 6 is equal to 4. Since the sign of the larger number 10 is positive, our answer is positive. For example B, we have 15 minus negative 8. That is equal to 15 plus 8. How did we get that? Again, our operation will be changed into addition. And our subtrahend, or the sign of our subtrahend, will be changed into its opposite, which is positive. That's why we had 15 plus positive 8, or simply 15 plus 8. And the sum of those two is 23. That's why the answer for example B is positive 23. Let's move on to the next example. We have negative 3 minus the quantity negative 2. On the right side of the equation, we have negative 3 plus 2. How did we get that? We got that by changing our operation to addition and then changing the sign of the subtrahend with its opposite, which is positive. And applying the rule in adding integers, negative 3 plus 2 is equal to negative 1. Next, negative 4 minus 15 is equal to negative 4 plus the quantity negative 15. And applying the rule in adding integers with the same signs, we add 4 and 15. That is 19, and since they are both negative, so the sign of our sum is negative.
We can also use sign tiles to add and subtract integers. So here are some examples. For number 1, if we are given 10 plus 2, so we are going to draw tiles. Okay. So for positive 10, we are going to draw 10 tiles showing the positive sign. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And for positive 2, we are also going to draw 2 tiles with the positive sign on it. Now, if that is the case, simply add all of the tiles with the positive sign. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the answer here is 12, and since all of the tiles are positive, so it is positive 12. And when the sign is positive, we don't have to write it before the number. Okay, so simply 12 or positive 12 is the answer in number 1. For number 2, we are given the problem 3 plus negative 2. So again, we represent first 3 as using 3 tiles, or 3 tiles with the positive sign on it. So we have 1, 2, and then 3. Okay, for the negative number, let me use another ink. So let's use purple. This time we are going to put the negative sign on the tile. So we have negative, and since we know that positive plus negative is equal to 0, so let us try to match the tiles so that we'll have zeros. Okay, so this tile and this tile, when we combine them, it is 0, so we will cross it out. And then another one, this tile and this tile, we are going to cancel it. Okay, so based on that, the sum of this is based on the remaining tile. So we only have one tile, so that is 1, and the sign of the tile is positive. It means that the answer here is positive 1, or simply 1. So 3 plus negative 2 is equal to 1. For number 3, so again we use the purple ink for negative 5. So I am going to draw 5 tiles. So 1, 2, 3, 4, and 5 with the negative sign on them. And then to represent positive 16, let us use blue ink. So I'm going to draw 16 tiles with positive sign on it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So let us put the positive sign on each tile. There you go, and then we can cancel the pairs, positive and negative tiles, so that is equal to 0. Okay, cancel, cancel these two, cancel, 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 and then counting the number of tiles left, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and all of the tiles are positive, so our answer here is positive 11. For number 4, we have negative 9. First, let us draw 9 tiles with negative sign on them. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So they are all negative. After that, we can withdraw one tile with a positive sign. We can cancel a pair of negative and positive tile, so we can cancel this, and we are left with how many tiles? We are left with 1, 2, 3, 4, 5, 6, 7, 8. And what is the sign of those tiles? Yes, they are all negative. So the sign of our answer, or the sum of -9 and +1, is -8. Next, number 5. So we have a positive number here. So +6. We will draw 6 positive tiles. So 1, 2, 3, 4, 5, and 6. And then let us put the positive sign. There you go. And then for -7, we have 1, 2, 3, 4, 5, 6, and 7. So that is, or they are all negative. And then we cancel the pairs. So we can cancel this, this, and this. So we are only left with this tile, and there's only one. Its sign is negative. So the sum of +6 and -7 is -1. Another example. So this time we have -2. So let's use a purple ink. -2, that means 2 negative tiles, and then +2, that we will draw 2 positive tiles, and then we cancel the pairs. Okay, so we are left with no tile at all. So the answer here is 0. Of course, you already know that 0 is neither positive nor negative, so just 0. Number 7, -4 plus -6. So we represent -4 using 4 negative tiles. 1, 2, 3, and 4. So those are all negative. And then -6, we are going to draw 6 tiles that are negative. 4, 5, and 6. All right, now there is no positive tile, so we are going to count how many tiles are there in all. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 tiles, but those tiles are all negative. So the sum of -4 and -6 is -10. Number 8. This time we have 2 positive numbers. So let us draw 7 tiles first. Positive tiles: 3, 4, 5, 6, and 7. So they are all positive. We are going to add 4 more for the addend. Okay, so 1, 2, 3, and 4. Again, we cannot cancel any pair, so we simply count the number of tiles, and there are 11. And since they are all positive, so that is the final answer. The sum of 7 and 4 is 11. Next, -9 plus -3. So they are negative. We are going to draw 9 negative tiles: 2, 3, 4, 5, 6, 7, 8, and 9. So that is negative. Next, we are going to draw 3 negative tiles: 1, 2, and 3. And of course, we are going to count all of them since we cannot cancel any pair. So that there are 12 tiles, and they are all negative. So the sum of -9 and -3 is -12. And for the last example, We have -3 plus -3. So they are both negative. So you have 1, 2, and 3. That is for this one. And then another 3 negative tiles. So we have 1, 2, and 3. We cannot cancel any. So simply count all of them. And there are 6 tiles, which are all negative. That means that the answer to number 10 is -6. Now, how about for subtraction? So let us look at the examples for. Alright, so for subtraction, of course, we have to follow the first step before we draw tiles. So our step again in subtracting is for us to change the sign of our subtrahend as well as the operation. Okay, so for number 1, we are going to change this. Okay, let me rewrite that. So we have 10, and then our operation will become positive, and then we take the opposite of -2. So we have um, again we take the opposite of +2, so that is -2. Okay, and then we can apply or we can draw tiles representing this number and this number. Okay, so for +10, we are going to draw 10 tiles that are positive. So 3, 4, 5, 6, 7, 8, 9, and 10. So they are all positive. And then we are going to draw 2 tiles that are negative. So we have 1 and 2. And of course, we will cancel what we can cancel. So we can cancel this pair and this pair. And if we are going to count the number of tiles left, we have 8, and that is, they are all positive. So our answer is +8. For number 2, we have this. So again, let me change first the operation as well as the sign of the subtrahend. So we have 3, and then our operation will become positive, and then the sign, we get the opposite of the sign of the subtrahend. Since it is negative, so it will become +2. So even if we do not draw sign tiles, we know that the answer here is 5. But for the sake of an example, we are going to draw tiles. Okay, so for +3, we have 1, 2, and 3. So put the positive sign. And then for 2, we have 1 and 2. Adding all of those tiles, so we have 5 tiles that are all positive. So the sum of 3 or 3 minus -2 is equal to +5. Example number 3, so we have -5 minus 16. Let us rewrite it first. So the minuend is still the same, -5. Our operation will become addition, and then +16 will be -16. Now we can represent them using tiles. Let's first represent -5. So we have 1, 2, 3, 4, and 5 negative tiles. And then another 16. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So those are all negative. And counting them all, they're all of the tiles are negative. we just count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So the result is 21 tiles that are negative, so negative 21. Simplifying, negative 5 minus 16, the result is negative 21. Number 4, we have negative 9 minus 1. Again, let us rewrite it first. The minuend is still the same, so negative 9. And then this sign for the operation will be addition, and then we have positive subtrahend, so it will become negative. Okay, now we can represent them using sign tiles. For negative 9, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Next, negative 1. So let's draw one negative tile, and that's it. Counting all of them, so we have 10 negative tiles. So the answer here is negative 10. Number 5, let us rewrite it again. So we have positive 6. This will become addition, since this subtrahend is negative, so it will become positive 7. So we have 6 plus 7, which is equal to 13. But again, for the sake of the example, so let us draw 6 positive tiles first. 2, 3, 4, 5, 6 for this. So let's put the positive sign. And then another 7 for the subtrahend, or for the addend. 1, 2, 3, 4, 5, 6, and 7. Counting all of those tiles, we have a total of 13 tiles that are positive. So we have positive 13. Next is number 6. Let's continue with example number 6. So we have negative 2 minus 2. Again, we're right. We copy the minuend, negative 2, and then the operation will become addition, and positive 2 will become negative 2. And then we can use sign tiles. So negative 2, we have, let's draw 2 negative tiles, and then another 2. Counting all of those, we have how many? We have 4 negative tiles, so that is negative 4. Over 7, that can be written as negative 4 minus negative 6. So we have negative 4 plus positive 6. Okay, so let us represent negative 4 first. We have 4 negative tiles, 1, 2, 3, and 4. And then 6 positive tiles, 1, 2, 3, 4, 5, and 6. Again, we can cancel the pair of negative and positive tiles. So cancel, 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 cancel. And we are left with 2 tiles that are both negative. So the result is positive 2. Or negative 4 minus negative 6 is equal to positive 2. Number 8, we have 7 minus 4. We can rewrite it as 7 plus negative 4. Okay, so we represent 7 first using 7 positive tiles. 2, 3, 4, 5, 6, 7. And then negative 4 can be written as negative 4 negative tiles. And we can cancel some pairs, cancel, 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 cancel. And we are left with 3 tiles that are positive. So we have positive 3 as the answer in number 8. Number 9, we have negative 9 minus negative 3. We have negative 9. It will become addition. And then negative 3 will become positive 3. And then we use sign tiles. First, we use sign tiles for negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. There you go. And then for positive 3, let's draw 3 positive tiles. 1, 2, and 3. We can now cancel some pairs. So 1, 2, and 3. Now we count what is left. So we have 1, 2, 3, 4, 5, 6, 6 negative tiles. So the answer here is negative 6. And for the last example, again we rewrite it. So we have negative 3 plus 3. Okay, so negative 3 first. So let's draw 3 negative tiles. And then 3 positive tiles for the add-in. So 1, 2, and 3. Cancel pairs of positive and negative tiles. This will be cancelled, cancelled, cancelled. There is no tile left. So we have 0. The answer to negative 3 minus negative 3 is 0. So I hope that through these examples you find it easier to add and subtract integers.
For multiplying integers, I will again show you examples and then try to observe as we come up with a rule that we can follow in multiplying integers. For example A, when we multiply positive 4 times positive 5, the result is positive 20. Example B, when we add negative 8, or when we multiply negative 8 times negative 9, the product is positive 72. And the rule that we follow is that if the integers have the same signs, their product is positive. Here is another example. 7 or positive 7 times 11 is equal to positive 77. With that, we can have this rule that when we multiply two positive integers, the product or the sign of the product is positive. Likewise, if we are multiplying two negative integers, their product or the sign of their product is also positive. Now, what if our multipliers have different signs? What will be the sign of our answer? Let's look at the next example. For example D, we will be multiplying negative 5 and positive 7, and the result here is negative 35. For example E, when we multiply positive 14 times negative 3, the result is negative 42. And when we multiply 20 times negative 6, the result is negative 120. What did you observe when we are multiplying integers with different signs? That is correct. If the integers have different signs, their product is negative. Or simply, positive times negative is negative, and negative times positive is negative. We move on to dividing integers. Again, I want you to observe the following examples and come up with rules that we can follow. For example A, when we divide positive 45 divided by positive 5, the result is positive 9. When we divide negative 81 divided by negative 9, the result is positive 9. And for example C, when we divide positive 77 divided by 11, the result is positive 7. What did you observe with the signs of our divisor and dividend? They are both, or they have the same signs. And what did you observe with our quotient? The sign of our quotient is all positive. With that, we come up with this rule that if the integers have the same signs, their quotient is positive. It means that the rule in multiplying and dividing integers are actually the same. Again, when we divide positive divided by a positive, the result or the sign of the quotient is positive. When we divide negative by a negative integer, the sign of the quotient is also positive. Now we have an idea about the rule that we follow in dividing integers with different signs. That is, when we divide positive by negative, the result or the sign of the quotient is negative. And when we divide negative by a positive, the sign is again negative. Here are some examples. When we divide negative 35 by positive 7, the result is negative 5. 16 divided by negative 2 is equal to negative 8. And negative 70 divided by 10 is negative 7. And 4 divided by negative 5 is equal to negative 4/5. But here is an exception. When we divide a number by 0, no matter what the divisor is or what the dividend is, as long as we divide it by 0, the result will always be undefined. Here is our rule that we follow again. If the integers have different signs, their quotient is negative. Now I want you to take note of those rules as we summarize using this song. Know, your integers. You can sing this to the tune of Row, Row, Row Your Boat, or you can use other tunes to sing. Okay, here is the lyrics for the summary of our lesson. Same sign, add and keep. Different sign, subtract. Keep the sign of the bigger number, then it will be exact. That is the rule for adding integers. Now here is for subtraction. Change the minus to a plus. Change the sign of next. Then all you do is add them up as if it were a plus. And lastly, for multiplication and division, multiply or divide, it's an easy thought. Same signs are positive, different signs are not. Here are some of the real-life applications of our lesson for today. For problem number 1, Felix reported that the coldest day on record for his town was 5 times colder than yesterday's temperature, which is negative 4 degrees Celsius. What was the temperature of the coldest day on the record in Felix's town? To answer that, we just have to multiply 5 times negative 4, and the result is negative 20 degrees Celsius. For example number 2, there are 336 oranges in 12 baskets. How many oranges are there in 3 baskets? To answer this, we just have to divide 336 divided by 12, and the result is positive 28, or there are 28 oranges in each basket. And for number 3, a vendor gained 50 pesos on the first day, lost 28 pesos on the second day, and gained 49 on the third day. How much profit did the vendor gain in 3 days? For that, we can represent the gains as positive and the losses as negative. To come up with our equation, which is 50 plus 28 or plus negative 28 plus 49 to get the result, which is 71. Now, aside from these examples, there are more real-life applications of our lesson, which I want you to identify and list down in your notebook.
Okay, so let's check how well you've understood the lesson as you answer the following as fast as you can. Okay, so 25 plus 8, what do you think is the sum of 25 and 8? Okay, that's right. Since they are both positive, so the result is positive 33. So we simply add the numbers and then get the sum, which is 33. For example number 2, or for problem number 2, we have negative 6 and then positive 6. So what will you do if they are both, or if they have different signs? That's right. So we are going to subtract the numbers. So 6 minus 6 is equal to 0, and 0 has no sign. So the answer to number 2 is 0. Number 3, so we have two positive numbers. We simply add 14 and 25. The result is 39. Number 4, we have numbers with different signs. So again, we subtract them. 28 minus 23 is equal to 5. That's right. And since the larger number is positive, which is 28, so we have positive 5 as the answer. Number 6, again, they have different signs, so we subtract them first. 36 minus 16 is equal to 20. And since the larger number is 36 and its sign is negative, so the sign of the answer is negative. So we have negative 20. Number 6, we have 19 plus negative 16. Again, they have different signs, so you have to subtract 19 and 16. So 19 minus 16 is 3, and the larger number is positive, so the answer is positive 3. Number 7, we have negative 15 and negative 4. We again subtract 15 and 4, so 15 minus 4 is equal to 1, and the sign of the larger number 15 is negative, so we have negative 1 as the answer in number 7. Number 8, negative 12 plus negative 12, they are both negative, so we add them first. 12 plus 12 is 24, and then adding them, or both of their signs is negative, so we have a negative as an answer, negative 24. Number 9, again we have two negative numbers, so add 24 and 16, the result is 40, and then copy the sign, which is negative. So the answer is negative 40. For number 10, negative 13 and negative 19. So we have negative 32 as the answer. Okay, continue. So we have subtraction this time. So the first step that you can do here is to change the operation into addition. So let me use another ink for that. So this will be addition. Okay, plus, 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 addition. And then reverse, or use the opposite of the subtrahend. Okay, so that is positive 11, it will become negative 11. 16 will become negative 16, 45 will be negative 45, 22 will be negative 22, 30, negative 30 will be positive 30, and then negative 19 will be positive 19, and then positive 18 will be negative 18, negative 10 will be positive 10, negative 18 will be positive 18, and negative 25 will be positive 25. To have a clearer view of the problem, so let us rewrite them. So number 16, we have 25 plus negative 11. Number 17, we have negative 2 plus negative 16. Number 18, we have 15 plus negative 45. Number 19, negative 11 plus negative 22. So we have negative 11 plus negative 22. Number 20, we have 12 plus 30. Number 21, 22 plus 19. 22, we have negative 13 plus negative 18. Number 23, we have negative 10 plus 10. Number 24, we have negative 20 plus 18. And 25, we have negative 15 plus 25. And applying the rule in addition, for number 16, the answer is 14. Number 17, we have negative 18. Number 18, negative 30. Number 19, negative 33. Number 20, 42. 21, 41. Number 22, the result is negative 31. Number 23, we have 0. 24, negative 2. Number 25, we have positive 10. So those are the answers for these problems. That ends our lesson for the operations on integers. Our next lesson will be on the properties of the operations on integers. I hope that you check and watch the video for this lesson. Once again, this is teacher Mary Jane. Until next time, bye.